So thank you everybody for joining us today. It's our real pleasure to hold this webinar and present to you the results of a piece of work that's been going on in the background quietly for quite some time now. So really great that we're now in this position to be able to share with you the results. So welcome to this launch of the new Safer Roads investment plans for vulnerable road users. So we're hugely grateful to the Road Safety Trust for funding this work, not least as we start to support local authorities and national highways in their work to improve important high-risk routes across our road network. This work will be absolutely instrumental in making sure that the safe system inspiration provided to road authorities through the iRAP system is as good as it can be and can help them progress towards zero fatalities on their routes. We've long considered the need to update the iRAP urban measures for walking and cycling to better support decision making to take us towards our health and active mobility goals. So that's why we're here, and just the usual guidance for a Zoom webinar. We're probably all very comfortable with this by now, aren't we? But just a reminder that if you have any questions, please do drop those into the Q&A box. And if you particularly like somebody else's question, you can upvote it by giving it a bit of a thumbs up. So that will make it rise up the pile. Do think about those questions that you have as we go through. We'd love to have a bit of interactivity at the end of the session. So just a very brief introduction to give you a bit of context, because some of you might not know too much about iRAP itself, and what we've done here in this project is very, very critical to the iRAP methodology. So you really do need to have that little bit of background. So bear with me if you are familiar. We'll just go through a few slides just to give you a bit of context. So iRAP is really geared up to meet the challenges of the safe system, and in the safe system there are two key principles. So the first is that humans make errors even when they're trying to be compliant, so crashes are inevitable. We make mistakes for so many reasons. We find it hard to judge two-way traffic movement, particularly at high speed. Our brains automatically filter out information, which is sometimes could have been pretty useful, like spotting a motorbike. It's called inattentional blindness. And we make slips, and the order of our routines sometimes get a little bit mixed up, a bit like when people put orange juice on their cereal and milk in their cup. Secondly, humans have limited tolerance to crash forces. So beyond certain speeds, our bodies just break. We are fragile. The survivability of side impact crashes beyond 30 miles per hour just falls off really steeply, and the same for head-on crashes beyond 45 miles per hour. For pedestrians and cyclists, outside of a protective metal box, the magic speed for survival is 20 miles per hour, hence the drive towards more 20 zones at the moment. And that's 30 kilometers per hour for those who are watching from overseas. We're still in miles per hour. We need roads, we need vehicles and speeds to work together to make sure that crash outcomes are survivable. And to do this, we have to proactively understand and manage risk, just like it's done in aviation and rail. Safe roads and road size is part of the safe system, and iRAP can help us with this. So iRAP provides a simple and objective measure of the safety performance of road infrastructure, providing star ratings for vehicle occupants, motorcyclists, pedestrians, and pedal cyclists. And it provides a detailed understanding of how risk changes along a route, with the detailed scores providing insights beyond what can be achieved with sparsely distributed crash data. The iRAP approach has been applied in around 100 countries globally, with 1.3 million kilometres star rated so far. Globally, we have a sustainable development goal to halve the number of road deaths this decade. And underpinning this goal, there are 12 World Health Organization global targets, and 2 of these are about road infrastructure, and the guidance refers to iRAP as a means of measurement. In the UK, the Road Safety Foundation is the programme lead for iRAP, meaning that we oversee and try to bring together the whole programme. We continually advocate for a safe system investment and try to support those who are applying the approach so that everyone can pull together with best practice. The programme is thriving, having been applied in more than 40 road authorities in the UK. Some highlights to mention from the list here: Other national highways have undertaken a survey every 5 years since 2010, and they're now really embedding the use of iRAP within practice and policy through a large-scale training programme. The Safer Roads Fund was a £100 million investment on local authority A roads, where we use the iRAP methodology to support practitioners. And there have now been 2 major road network surveys, one in Kent and the other in West Sussex, which are really important because of the high crash risk and the high crash density that we see on the major road network. And of course, we've undertaken many single road, can't even speak today, many single road surveys as well, all the way across the country and indeed into Scotland. So there are plans also now to create the world's first 5-star village in Horsford, and the parish council there just needs a little bit more money to see those plans through. Broadly speaking, the process in iRAP is that we undertake a survey and coding. The survey is video data that's captured or harvested, and then the coding is done by an iRAP accredited coding team. And the data that's generated are used to model risk based on safe system principles. From this, fatal and serious casualties are estimated, and then the model triggers countermeasures that are likely to address the type of risk detected. It's based on a set of logical algorithms. For example, in simple terms, if there's a curve and a tree at the roadside, remove or protect the tree, that sort of thing. Then the countermeasures are tested in terms of their casualty reduction potential to drive an economic appraisal of the measure, providing the cost of implementation versus the monetary benefits of saving lives and serious injuries. This project relates to that last couple of steps, where the model generates a safer roads investment plan, a treatment plan for that route that should be suitable for treating risk. Here, what we're trying to do is to enhance the utility and breadth of the urban measures in that safer roads investment plan. I'm going to hand over to Kate Fuller, who is Road Safety Foundation's Road Safety Engineering Director, who will then be able to introduce you to the project. Kate.
Thank you, Susie. Thank you. So in December 2019, the Road Safety Trust awarded the Road Safety Foundation a grant to undertake a project named Enhancing iRAP Investment Plans for Vulnerable Road Users. So there's been a considerable shift in recent years, which recognises the shortfalls of traditional car-centric road designs in urban areas. Some major cities across the world have fundamentally changed their approach to designing and managing their urban road networks, which prioritises safety and mobility for pedestrians and cyclists. Changes to road user groups themselves, such as increased cycling and micro-mobility, are also prompting cities to look for ways to provide safer urban road environments for all road users. As a result of this shift, there's now an emerging body of knowledge which captures the safety outcomes of the innovative treatments of those new approaches to urban road design. Much of it's already been documented in road safety manuals and guides such as NACTO's Global Street Design Guide and the World Resource Institute's Safer Streets by Design and other road safety manuals. The iRAP tools provide various outputs that are useful when reviewing the safety of a road network. The star ratings and casualty estimation functionality allows authorities to gain an understanding of how risk changes along an individual road section or across a network based on the safety performance of the infrastructure itself. So this project provided an opportunity to build on this innovation and capture the latest treatments for vulnerable road users that can be immediately deployed through the well-established activities of the Road Safety Foundation in the UK, iRAP across Europe, and iRAP with its global programme reaching over 100 countries. Importantly, this work closely links the UN member state global road safety performance targets, which inform and influence road safety policy and practice in the UK and internationally. Next slide, please, Susie. Thank you. So the overall objective of the project was to improve the safer roads investment plans generated by the iRAP approach, to ensure the latest thinking and innovation for safety measures for vulnerable road users in urban environments are fully embedded for road authorities to use to help them make the case for investment to prevent VRU fatal and serious injuries. That's very long. Thank you, Susie. Next slide. So work commenced in January 2020 with understanding what the needs and the requirements of local authorities were in the urban environment. To this end, we worked with a steering group which included Hampshire County Council, Kent County Council, Solihull Council and Transport for Greater Manchester to develop a user requirement document. An extensive review of the literature was undertaken to consider the effectiveness of urban VRU treatments in different scenarios, and the information was captured. Based on the work undertaken in defining the requirements and the literature review, a list of appropriate measures was defined. Once this list had been identified, they were developed and categorised according to the evidence base available to substantiate the countermeasures risk modification factor. Those found to be relevant and with an adequate evidence base were included in the testbed for piloting. Next slide, please. Thank you. For the pilot, a search of the data in VIDA was undertaken to see if there were urban routes which could be used to test the countermeasures. A gap analysis revealed that more iRAP surveys were required and extra surveys were undertaken. The testbed was then created by the iRAP team and the new countermeasures tested in real life. The data sets were run on the testbed to identify the locations where the new countermeasures would be triggered. Maps showing the location where the new countermeasures triggered were shared with local authorities and feedback was sought. Amendments to some of the countermeasures were made and the changes included in the iRAP model. Next slide, please. Thank you. So the initial feedback from the local authorities was good. They felt that the countermeasures generated on the stretch of roads in their area were adequate for the urban environment, and they felt that they could increase road safety for car occupants and vulnerable road users. They also agreed that the new countermeasures represent changes in the urban infrastructure they already implement, and therefore there's a need for such countermeasures in their urban area. Finally, they agreed that the new countermeasures are aligned with a safe system approach. The updated tools are freely available and will help authorities to better analyse their urban road networks and identify cost-effective improvements targeted at reducing fatal and serious injuries in all user groups. I'm now going to hand over to Shanna, who will give you an overview of the changes and show you VIDA. Thank you, Susie. Thanks, Shanna.
Hello, everyone. Thank you, Susie. Thank you, Kate. It's an absolute pleasure to join you today to tell you more about the enhanced urban safer road investment plans of iRAP. So I'll be calling safer road investment plans as STRIP and vulnerable road users as VRUs because I'll be repeating those same words a few times during this presentation. So as Kate just presented, the project's primary goal is improving the safer road investment plans to ensure that the recommendations provided by iRAP will incorporate solutions for VRUs in urban environments aligned with the safe system and Vision Zero approach. So we know that operating speeds play an essential role in VRU safety. So many of the new countermeasures I will show you today will focus on reducing urban traffic speeds for the safety of road users. So we truly believe that the urban enhanced strip has helped to rethink the engineering measures used in road design to encourage lower speeds and create more equitable and accessible roads. So therefore, local authorities can benefit from the enhanced urban strip to include countermeasures in their investment plans that stimulate low speed, and also because the suggested infrastructure changes aim to be more aligned with the urban needs and accounting for the variability and the dynamics of the urban environment. Next slide, please. So different research has been conducted and is currently available on VRU safety and urban countermeasure. We explore the current knowledge in the literature review part of this project, so please get in contact with us if you want to have access to it. And what you see in this slide is the 9 outcomes of the literature review that guide the implementation of the enhanced strip. So we start with the introduce speed reduction as a countermeasures that account for the traffic calming measures appropriate to the target speeds, recommend appropriate traffic calming measures for all urban roads where pedestrians and cyclists are present, consider the introduction of traffic volume reduction as a countermeasure through area-wide traffic calming measures such as diverter, closure, and street conversions. And let me say a special note on this one. We introduced the traffic calming reduction countermeasures in the preliminary version of the new enhanced urban strip that I will show you today. However, based on the feedback we received during the pilot, we decided to exclude it from the final version. The vehicle flows reduction countermeasure aim to flag areas with high pedestrians and cyclist activity, where the decrease in vehicle traffic flow will increase the safety and accessibility for other road users, and perhaps enable the installation of safer pedestrian and cycling facilities. But in the end, the countermeasure was triggered in very strategic roads where reduced traffic can be a complex task that will demand more than infrastructure change. So to the strip continue to include feasible recommendations, we decided to remove these countermeasures for the final version. So continuing in our list, so the number 4 is broaden the type of pedestrian and cycling crossing types. 5 is enhance upgrade crossing qualities with a specific list of recommended measures. I will jump to the 7, that is introduce measures to reduce lags on junctions, on closed junctions closed junctions to vehicle traffic. And then number 6 and number 8 deal with the update of the minimum lane, minimum spacing, and hierarchy rules in line with current best practice, and update trigger sets. I don't know if everybody in the audience knows, but the iRAP models allows for several application rules for certain countermeasures in addition to the triggers. So countermeasures that satisfy these rules are considered for inclusion in the SHRIP. We apply 3 types of rules. So it's minimum lane, minimum spacing, and hierarchy rules. An example of a minimum lane rule is that additional lanes, such as overtaking lanes, must be required for a minimum of 1 kilometer before they are considered viable to the SHRIP. So in the case of minimum spacing rules, a good example is grade separated pedestrian crossings, which must be at least 1 kilometer, that is 10 consecutive 100-meter road segments apart. Because if we did not have this rule, the model may recommend this countermeasure every 100 meters, what will not be feasible for any environment. So finally, the hierarchy rules organize countermeasures in order of their potential to reduce death and serious injuries from highest to lowest. So in the case of a footway, for instance, the first one in the hierarchy order is the footway provision passenger side with barriers. And the last one is the footway provision passenger side informal path less than 1 meter. That is, all other things being equal, the installation of footway provision passenger sides with barrier is preferable to all other footway types. So if you have questions about the rules, you can always access the fact sheets that I presented in our website. And the 9th point, so the last one, is to enable more than 2 countermeasure outcomes. So currently in the standard SHRIP, countermeasures included in the SHRIP will produce change in 2 attribute maximum to calculate the after start ratings. We are now allowing for 3 because some of the new countermeasures require 3. So if we can move on to the next slide, please, Susie. Well, let me now run through all the new countermeasures that we will be able to find in the new SHRIP. The first package of solutions relates to safe speeds. We start with speed control. So the speed control countermeasure is recommended when drivers continuously disrespect the speed limit. They can be implemented as vehicle active signs or speed cameras and have educational or punitive purpose. The countermeasures will be triggered near schools or crossing points when the speed limit is adequate for urban areas, but operating speed is above the speed limit. Then we go to the speed limit reduction. The speed limit reduction is recommended on urban roads where the land use indicates the possible presence of VRUs and the speed limit is above 30 miles per hour. So the model will trigger these countermeasures around school, close to crossings, and where pedestrians or cyclist flows, it's high. We are splitting these countermeasures into 2 because you may agree that only changing the speed limit size sometimes is not enough. Therefore, depending on the level of enforcement, we will have a different outcome for these countermeasures. We expect a high reduction of the operating speed in the locations when the new speed regulation is strongly enforced, compared with roads where enforcement is not so present. So if we can move on to the next one, please. So continuing on the safe speed package, we enter the traffic calming world. So the standard version of the SHRIP already has a calming traffic countermeasure, but it's quite broad, and the only outcome expected is the change of the traffic calming attributes to present. Here, we propose a more holistic perspective, providing countermeasure and impact on the operating speed for each speed range. So also, several different types of traffic calming devices can be implemented to encourage drivers to reduce speed. Most of them are speed specific. So, for example, traffic calming measures to reduce speed below 20 miles per hour can be, for example, vertical deflections, like flat-topped road humps, but rumble devices, for example, are preferable in the case of 40 miles per hour. So the speed limit really play a role in the type of traffic calming that we are implementing. So these countermeasures will be triggered to encourage speed limit compliance where the operating speed is higher than the speed limit. Also, when there is no traffic calming present and the land use indicates the possible presence of vulnerable road users. Some of you mentioned in the feedback that the UK do not usually implement traffic calming measures for roads where the speed limit is 40 miles per hour or more, but you can always ignore this countermeasure on VIDA, and I will show you how to do it later. Then the traffic calming lane width and number of lanes are particular types of traffic calming measures on the street, mainly because they are seen as continuous measure along the sections and not punctual intervention. So in the case of lane width, we are the redistribution and better use of road space, accommodating the different road users' demand. So by reducing the width of the traffic lane, drivers might feel less comfortable to speed up, and then they will reduce their operating speed. The presence of cyclists on streets where they need to share space with cars will also trigger these countermeasures. In this case, the lane width reduction can promote an area to a dedicated cycling facility. These countermeasures can also be used to reduce the number of lanes, which might enable space to reshape or a repurpose of the space for a range of different users. And a reduction in the number of lanes will be triggered for roads in undivided urban areas with 2 lanes or more, and where the speed limit is also below 50 miles per hour. So next slide, please. After the safe speed package, we include a package of countermeasures for safe crossings. So diagonal crossings are intended to be implemented in signalized junctions only. They are recommended for crossings with large pedestrians and traffic volumes. Therefore, the countermeasure will be triggered in urban 4-leg signalized junctions with or without protected turn lanes, where crossing flows are higher than 100 pedestrians in the peak hours, and when road AADT is greater than 10,000 vehicles. We are also implementing the signalized junctions with diagonal crossing as a countermeasure, which combines the trigger of the existing countermeasure signalized junctions 4 legs and the new countermeasure diagonal crossing. It aims to guarantee that the diagonal crossings are suggested when the model recommended signalized junctions as well. The next one, so pinch point giveaway crossings are recommended for mid-block locations with low traffic volumes and where speeds are less than 20 miles per hour. So when implemented, the road is reduced to 1 lane at the crossing point, and traffic gives way to approaching vehicles. So the countermeasures here will be triggered in the urban streets where mid-block crossing flows are present and operating speeds are less than 20 miles per hour, and finally when road AADT is below 3,000 vehicles. On the other hand, the staggered crossing will be triggered in mid-block section as well, but where a median greater than 3 meters in width is present. It will be recommended where there are 2 or more traffic lanes per carriageway, and even and when pedestrian flows are low. In this case. Operating speeds and vehicle flow triggers will limit staggered crossings to a AADT below 10,000 vehicles and operating speeds between 20 and 50 miles per hour. The staggered crossings are configured as crossing legs on each side of a refuge and are slightly offset so the pedestrians face the direction of the oncoming traffic, increasing pedestrian visibility. It can be implemented as an actuated signalized crossing as well. So next slide, please. So continue with safe crossings. We have here the flush crossings. So flush crossings reduce pedestrian movement barriers and remove the implicit priority of vehicles by raising the carriageway to level with the footway, as you see in the picture. This countermeasure will be triggered in junctions where the side road volume are low and pedestrian and cyclist flows are high. Next one, please. So you might know that junction channelization is one of the attributes we code in the star rating assessment. We know from research that compact urban junctions reduce the conversion speed and reduce also the crossing distance for pedestrians, producing safety benefits from those users. So therefore, we include now a new countermeasure in the safe junction package, And the recommendation is to close these channelizations in urban areas. By eliminating channelization, we can consolidate the conflict points and reduce the junction ready. The countermeasure will be triggered at junctions where the channelizations occur and row ADT or side road volumes are low and pedestrian or cyclist flows are high. Next one, please. And we are almost finished with the new countermeasures, but let me just talk about the safe junctions now. So safe junctions also include the minimum roundabout countermeasures. Mini roundabouts were already included in the possible coding for junctions, but there was no recommendation to implement them in the standard strip. So this new urban enhanced strip, actually the iRAP standard strip already include roundabout as one of the possible countermeasures. However, they are triggered on relatively busy roads where vehicle travels at 55 miles per hour speed or less. So the mini roundabout countermeasure will be triggered at 3 or 4 leg junctions when the operating speed is 30 miles per hour or less. And the roads need to be undivided urban roads with low peak cyclist flows. Next one, please. So we finally get to the last group of new countermeasures that are related to the safe pedestrian and cycling facilities. We know that some of these solutions are not regularly implemented in the UK, but their safety, social, and economic benefits have been demonstrated in other countries and have been included as the iRAP model is like international model, right? So pedestrian and cyclist zones aim to create more space for pedestrians and cyclists, permanently restricting vehicle access during specific periods of the day. So they are considered road safety measures because after the implementation, the conflict between pedestrians and cyclists with vehicles are completely minimized. This countermeasure will be triggered in urban commercial areas where pedestrian peak flows are greater than 400 and there is no cycling facilities, when the speed is low and the AADT is also low. Unlike the pedestrian and cyclist zones where vehicles are not allowed to enter, only maybe emergency vehicles, but the bike streets are a mixed traffic streets where cyclists have priority over cars. So this type of facility, also called car as guest, is showing in the right picture. So the bike street countermeasure will be triggering undivided urban roads in residential areas with cycle flows and no cycling facility. Operating speeds and road ADT need to be low as well for the countermeasure to be triggered. We also added the protected off-road cycle lane countermeasures to recommend the implementation of protection barriers on the side of new cycling facility on high-speed roads. So we will continue to have the bike on-lane and off-road, on-road and off-road types of countermeasures. But for very high-speed roads, we recommend now the protected off-road cycle lane. Next one, please. So we have also made changes in the existing countermeasures to make them more urban friendly. As I mentioned, urban environments are very dynamic and the infrastructure needs to prioritize accessibility and vulnerable road user safety instead of traffic mobility. So the main change in the existing countermeasures relates to the minimum space and lane rules. As you can see on the screen, the standard strip includes cycle lane requirements and crossing as part of the investment plan. So it says that cycle lanes only are included if they are triggered for more than 300 meters. We are removing these requirements in the enhanced urban strip. And something similar happens with the crossings. So the 3 types of crossing you see on the screen cannot be triggered for more than 200 or 500 meters. This means that if an unsignalized crossing is recommended in 2 consecutive 100-meter sections in the model, it will only be implemented in the first one. So the enhanced urban strip is flexible in this case for urban areas, allowing crossings to be triggered in consecutive sections. Next one, please. So in total, we are adding 20 new countermeasures in the urban enhanced strip. Considering that now we have countermeasures for mile per hour and kilometers per hour, since some of these countermeasured outcomes are changed in the speed limit and operating speed, so we need to create countermeasures for both systems. And the change in the existing countermeasures that now have specific requirements for urban areas. So if you look at the urban enhanced, you will see that these are existing countermeasures, but now we have specific rules for the urban areas. Next one, please, Susie. So comparing the standard version of TRIP that some of you might already know with the enhanced one, you can see that you have access to the existing 92 countermeasures plus the new 29. So we decided to maintain the current countermeasures in the enhanced urban TRIP because some of the projects and some of the networks that local authority access using the star rating methodologies are not entirely located in urban areas. So it's quite common that we have a mix of urban and rural environments in these networks assessed. So we'll still need countermeasures for the rural area, even in the enhanced urban TRIP. As you may know, the standard TRIP has been used and is suitable for both environments, but this new version is introducing this new countermeasure developed especially for urban areas. It's also important to notice that the regular countermeasures package is still the standard option in VIDA. So you have to select the enhanced TRIP on VIDA if you want to use it. Also, you will need to ignore the countermeasures in kilometers per hour and choose the level of enforcement the project will receive to make the suggested investment following your regulatory and political context. So of course, if you are in a country that uses kilometers per hour, you need to ignore the miles per hour countermeasure, and vice versa. In the case of UK, you need to ignore the kilometers per hour countermeasure, and I will show you how to do it in a moment. So finally, the cost benefit analysis remain precisely the same. So you have to include costs for the new countermeasures as well, if you want to use them in your project. Next slide, please. So I don't know if anyone have any questions so far. If not, I can show you how it works on VIDA, and maybe Susie, I can share my screen now.
Shanna, we do have some questions.
All right.
Maybe we can take those and then we can delve into VIDA and demonstrate things. So Simon asks, how is the value of life calculated in order to determine the cost benefit? I can take that one because you get to define that yourselves in your own iRAP project. We would typically in the UK use Department for Transport's values of prevention. So we just plug the figures, the official figures into that. If you're from a country where you don't have official defined values of prevention, then VIDA will calculate a value of prevention based on GDP multipliers and so on. But that's probably not the case for you, Simon, I would imagine. So we've done that one. Can we get this presentation? I'm sure we can probably PDF it and send it out. So that's an easy one. Thank you, Carlos. Nigel has asked, I'm slightly concerned that grade separated pedestrian crossings will be promoted. We've removed them as pedestrians tend not to use them. Kate, would you like to answer that one live?
Yes, thanks Nigel for that. I think basically this is an international model, so it's there for the international side of people. I think that these things can be ignored, as Shanna has said, so please don't worry about that too much.
Yeah, and actually some of what the iRAP model was doing in the urban environment was very, very much about segregating pedestrians and cyclists from motorised traffic. But what we've tried to do in this project is to talk about making road environments more holistically suitable for mixing pedestrians and cyclists and motorised traffic. So actually the emphasis now will be less on grade separated pedestrian crossings and pedestrian guardrail, but more on the sort of holistic approach to the road environment to make it more suitable. I hope that helps. Nigel's also asked what's the criteria for rural versus urban. Kate, have you managed to
Hi, yes, I've got this, thank you. So it is in the coding manual, and urban is defined as a development spanning at least 400 metres along the road. Small isolated settlements of less than 400 metres may be coded as changes to land use where there are sites of high intensity activity. And then a rural is an area outside of an urban area or rural town or village, or where roadside development does not impact the road, or where it's separated by a large fence or wall. So it's quite specific in the coding manual.
Yeah, if you want to visit any of the codings definitions or anything, they're all published on the iRAP website in the coding manual under, I think, specifications.
That's it.
You can never remember which bit of it, but if you
specifications,
if you need help finding it, then let us know. Mark Reynolds has asked a question that I have on the tip of my tongue as well, about whether any of these findings will be included in the Manual for Streets 3. I don't know is the answer. There's no plans at this point, and it would be great to explore the compatibility of what we're doing in the urban environment, in particular with Manual for Streets. I've not seen Manual for Streets 3 myself, but maybe we can explore that possibility of having that sort of cross-check of how things are sort of lining up. Tony says, whilst good in reducing vehicular collisions, it was assumed previously that collisions at mini roundabouts, especially forearm, were overrepresented for cyclists and motorcyclists. Do iRAP studies now provide some evidence against this? Shanna, are you able to take that one?
Yeah, I can take this one, and I think we agree with you. What we are trying to do in the triggers is that this countermeasure of mini roundabouts, it will only be triggered if the bicycle's peak hour flow is very low. So just to make sure that we are not adding risk for cyclists when recommending this countermeasure.
Thank you, Shanna. So I think that's it on the questions so far. So yeah. Oh, hang on, we've got another one. We've got another one, sorry. Simon has asked, what is the SRIP doing to try and change attitudes? Mixed cyclist stroke pedestrian streets are fine until cyclists ride too quickly. Bike streets are fine until cars park on the street. I suspect there will be some who will react against these very worthwhile measures and will continue to ride quickly and park badly, or at least not adopt the communal ideas. Until attitudes change, this would seem particularly important in this holistic mixed approach. Oh, I think that one's going to take a bit of thought, isn't it? We might come back to you on that one, Simon, because I'm not sure that I can think of a sensible answer on my toes on that one. But you're right that we can suggest countermeasures, but unless they're used as we want them to be used and expect them to be used, then their effectiveness is going to be different. And I don't really think that, other than ensuring that in the iRAP model we have a reflection of how the countermeasure is likely to be used as opposed to how we ideally want it to be used, unless we have that, then we're not going to achieve as good a result as we might, but we'll give that some more thought. Thank you for your input.
Yeah, and Susie, let me just add, because in the case of cyclists, we are trying to address these issues with CycleRAP. So CycleRAP is the other iRAP model that we launched a few months ago. It's specific for cyclists, and then we try to capture a little bit these conflicts, especially between cyclists and pedestrians in the CycleRAP model. So this might be a new webinar, but you can always access the CycleRAP website and take a little search on that to have more information on how the model deal with these conflicts in those types of roads, like bike streets, for example, or pedestrian and bicycle areas, share areas.
Thank you, Shanna. So I think it's back into Vida, if you will, Shanna. Thank you.
Okay. All right. Let me see if I can quickly share my screen. Can you please let me know? Let me just close the questions in here. Can you see my screen now?
Yeah, absolutely, it's there.
Okay, perfect. So let me just do that. Okay, so let me also just set the language here correctly. Okay, so if you are used to create projects on Vida, you will see that the process remains exactly the same, like the regular iRAP project. I have a project already created here, so I'll add it to show you where to choose for the new countermeasure package. So let me see if my internet connection will allow me to do that. I hope so. But I have a project here in the sandbox that is ready for the webinar. Oops. Please be patient because my connection is not that good today. Okay, so here we are in the dataset edit. So as you know, you should configure all the stage as the project requires. Then in stage 6, there is the investment plan. And here you can also include those values of Vida that Susie was mentioned to you before. But going down here to the countermeasure pack, so the standard option is the V3.02 countermeasure. But if you click here, you will see the V3.02 countermeasure urban enhancements. So this is the one that will be including all these new countermeasures that I'm showing you today. So if I maintain this first option just for you to show you, you can see that here we have the 92 countermeasure costs, like the regular ones. But if I change here to the urban enhanced, okay, so the system will ask me to save stage. I will do that. Oops. Okay, and now if we going down here, you will see that these new countermeasures are already added here in the countermeasure package. So I will just add the costs because we will need them for me to show you how it works. So the countermeasures cost is required. So my costs are already in here. And we need now to ignore the countermeasures in kilometers per hour, since the road we are assessing in this example is in UK. So I will choose here to, let me find them here, ignore the countermeasures that are in kilometers per hour. You can always do that with all the countermeasures in the countermeasure package, but I will just do that to not overlap with the mile per hour countermeasure here as well. And we also need to select our level of enforcement. So I will say I will expect a high level of speed enforcement on those roads. So I would say that the speed limit reduction will have a strong enforcement and will comply with the safe system. Okay, then I need to save stage. Oops. And I just need to process. So upload my data sets and process. Here I already have my data sets uploaded, so I will reprocess them. So you receive that message that your data set has been scheduled for processing, and for us not wait too long for the processing, I already have a data set processed here to show you. So I just want to show you that if you go to the investment plans and the street table, now if you selected the urban enhanced countermeasure package when you are setting your project, you will be able to see the new countermeasures in here as well. So let me go down to find a few in here. I know I have some very right on the bottom. So here, as you can see, I already have traffic calming target speed 30 miles per hour, traffic calming target speeds 4 miles per hour. So our new countermeasures that are that were triggered and passed through all the cost and benefit analysis that the model always conduct. Here you also can see the speed control. There is a new countermeasure for the package, the speed limit reduction, safe system compliance, strong enforcement that we just selected. So it will work as you can see, we will work as a regular iRAP project. You have all the current resource available on VIDA to analyze this countermeasure. So you can download this data in the download section, including the new countermeasures. You can click on the countermeasures to see, for example, on the map where these countermeasures will be located. So feel free to start using this new version of the script. And we hope the new countermeasures added will be useful to make your urban areas compliant with the safe system approach and improving the travel experience, especially for vulnerable road users. So please provide us with any feedback you might have after using it, and because we will be continuously working to improve this new feature. So it's basically it. As you can see, it's super simple. We just need to select in the data set settings that you want to use this new package, that the system will include these new countermeasures and proceed as a regular iRAP assessment. So I think that's all. I don't know if anyone have any other questions about it.
Thank you so much, Hannah. We've got a couple of open questions. I think they might not particularly relate to the piece that you just did, so bear with us. One question is, in order to propose intersection solutions, what alternatives are there?
In terms of intersections, I mean, we are more concerns on crossings specifically in this new urban enhanced street, because we are very focused on VRUs. So we are providing solutions especially for VRUs, not necessarily for cars in this new package. So I think that would be my answer for this one.
So Carlos, if you want to know more generally about the iRAP model and the intersections, intersection upgradings and solutions that are proposed, then you might want to have a look at the iRAP website. Again, there are fact sheets for each of the countermeasures included in the model. You'll be able to find out some bits and bobs there. And if you have any specific questions, don't hesitate to come back if you can't find what you need. John Burrell, I think this is more of a comment than a question. He's absolutely right. So as with all road safety countermeasures, they can't be implemented in isolation, and any countermeasure has to reflect local road user behaviour. A strong emphasis on road user education has to be included if you want to introduce something new or change attitudes. So yeah, where you've got a completely new configuration of junction or crossing type or whatever, then you have to obviously pair that with education and knowledge amongst the road users. I think the other thing to bring in is that we've been working really hard on tools in the UK that will eventually be used all over the world for tailoring safer roads investment plans. So the model will give you an answer. The model won't know everything you know about your own road network. So the idea is that the tools that we have been working on will allow you to tailor and pick and choose from what the Safer Roads Investment Plan is proposing, but also come up with your own solutions that you think would be most locally appropriate in your road environment. So just bear that in mind, that the Safer Roads Investment Plan is simply a starting point to give safe system inspiration to practitioners, and then you get the chance to apply your own knowledge, expertise, and understanding of how people are likely to use the measure, and all of that stuff, like the stuff that you can bring in. We've run out of questions. Has anyone else got any last minute questions on the urban SRIPs? Oh, we've got one more. So Simon says, I took a ROSPA course some time ago, and there's much discussion about the use of near misses rather than KSI figures, mainly because there are many more near misses than KSIs. Since then, CCTV, etc., is much more common. Are there plans to use video to detect near misses and therefore be able to identify measures before there are accidents? Shall I take this one? So I've seen some systems recently that absolutely trace vehicle movements and absolutely help us to understand near misses. Under the safe system, near misses for me are a little bit difficult, and the main reason for that is the roundabout. Now, I'm not sure how many examples there are like a roundabout in this, but bear with me. So normally in health and safety, we say there's an iceberg, you see the tip of the iceberg in the actual instance, and then you've got to look underneath the water to see all of the other stuff that might give you some clues. And this is what we're talking about here, using near misses to help inform. Now, in the safe system, we're only really interested in preventing death and serious injury. We're not interested in preventing collisions per se. So it's a bit of a mindset change whereby, because people have limited processing and have particular ways that their brains work and so on, we expect there to be crashes. We're quite happy for there to be crashes as long as they don't end up fatal or serious. So we'll give you an example of the roundabout. So the roundabout typically will have more collisions than a T-junction or crossroads. However, the angles that you get at a roundabout are this kind of impact angle where you get the glancing blows rather than the side impacts. The glancing blows are very survivable typically. They, we don't tend to see lots and lots of fatal and serious injuries at well-designed roundabouts that deflect on entrance and make people slow down, and you get the nice angles and so on. If they're badly designed, that's not the case, but bear with me on the good design of roundabouts. T-junctions, you get your side impacts where the vehicle can't protect you very well, and that's where you get your death and serious injury. That's why we say survivable speeds at T-junctions and crossroads are only 30 miles per hour, really, in truth. And beyond that, your risk of being very seriously injured goes spiking up through the roof. So I'm always a little bit uneasy about using near miss data to drive our decision making. So the whole reason for looking at near miss data is because we don't have that many fatal and serious and even slight crashes on our network. So we're sort of grappling around for more intelligence to help direct our efforts. What we think is important instead is to understand the opportunity for fatal and serious injury and risk, rather than looking at historical incidents to tell us where future incidents might be. So that's where the iRAP methodology comes in. So instead of using near misses to drive our decision making, which could be slightly flawed from a safe system perspective, what we're doing is we're trying to appreciate how risk changes along a route, pick off the risks that we can treat with good returns, and therefore prioritise in that manner instead. So it's a little bit of a different mindset from traditional health and safety approaches generally, I would say. I don't know if that helped, Simon, but happy to have more discussions on that, because this is something that comes up from time to time, and we can always show you a little bit more about the risk profiles that are outputted in the iRAP system that can really give you that sort of picture as to where your priorities are, because we model risk at the 100-metre location. You get this really sort of rich kind of picture being built up. You also have the number of fatal and serious injuries modelled at each 100-metre location, broken down by crash type. So you end up with this massively rich picture of how risk is changing along the route. So actually, do we need the near miss data to drive our decision making when it could be flawed from a safe system perspective? Sorry, that was a long answer. We've got some more coming in whilst I've been yabbering on. And Mark says, if you look at near misses, it would be biased based on collection location. Of course, you're only going to detect them where you are trying to detect them, not everywhere. So yeah, that makes sense. Thanks, Mark. Nigel says, where people perceive a junction as dangerous, they tend to take more care. Oh, absolutely. I love a bit of psychology in all of this. It's similar as well when you play tricks on people as you move into an urban area with a very tall, high built up gateway treatment. It can make the road look narrower and look a bit more kind of tight and scary. Actually, that then makes people drive more slowly. So absolutely, sometimes it's good for a junction to look more dangerous, but hopefully we also still manage actual speeds at a junction to then be survivable for vehicle occupants, but also for any non-motorised traffic that might be at that location. Shanna, come in if you want to chip in. Same Kate. Sorry, I do tend to talk a lot.
No, but it was brilliant. I was just want to say that actually we were just to start a project that will be looking to near misses in some ways, because we will be working with like virtual simulation scenarios and road safety together and see how can we create like dynamic road safety assessments. So it's a research project. It's a 3 years research project. So we'll be things for, you know, next chapters to discuss exactly how this is going to work together with the iRAP models. But it's I totally agree with what Susie just said, but it's something that is in our radar, and we will be working with some of these new types of road safety data in these innovative projects that are just about to start.
Plenty to be going on with. Askew says, a damage-only accident still recorded as part of the Stats 19 data? I think the theory is they can be, but they are very rarely. Certainly, the level of completeness of our Stats 19 data increases with severity. We pretty much capture all the fatals. We capture most of the serious, but with slights and damage only, I don't think that we have enough resource to adequately capture those, and so they very rarely are captured. I mean, I've definitely been involved in a couple of collisions. I shouldn't say this under the safe system, but not my fault, because that's irrelevant. But ultimately, I know that they weren't included in the Stats 19 database, even though they had the potential to be quite severe and serious. So yeah, no, very rarely, I would say. Nigel says damage-only collisions are normally recorded only where the police think they can prosecute the driver. Yes, it's this kind of traditional focus on blaming the driver kind of ethos, rather than looking at, ideally, when you're investigating a collision, you should really be looking at what the system failure was that allowed that crash to be fatal or serious. That's really the safe system approach to crash investigation that we're after. But that doesn't typically happen at present, though I think DFT are looking at changing.
Can I just add to that as well, Susie, if I may? So because the data for Stats 19 is collected by the police, if the police don't attend a crash, then there's not going to be any Stats 19 data. So it's really unusual, as Susie says, for damage only to ever be reported in Stats 19. Plus the fact that they used to say that for every recorded personal injury accident in Stats 19, there'd be up to 8 damage onlys that were never reported. So just wanted to clarify. Thank you.
Yeah, thank you. Reading live. Anyone else got any other answers? Simon's got another one. Simon's really testing us today. Thank you, Simon. Change of approach makes sense if measures are installed using cost-benefit analysis. I suppose that the historical data is necessary, which means that there must be an accident to justify the expenditure. But if measures are installed according to perceived risk, I suppose that is possible to do without any actual accidents. Very interesting. Yeah, so that's it. So we're going through a process at the moment to assure the use of modelled fatal and serious injury reductions in appraisals on the strategic road network, which is a really interesting process to go through, and it's looking very positive at the moment. So absolutely using the modelled expected fatal and serious injuries and the potential for measures to reduce those expected fatal and serious injuries along a whole route allows us to take that holistic route-based treatment approach, whereas responding to individual measures, sometimes it's really hard actually to come up with a coherent route treatment because they're so sporadic and random and they don't provide good prediction of future incidents. So yeah, absolutely that, Simon. Really pleased to discuss that more with you in the future. So we are at the end of our hour. It is 11 o'clock, and I'd like to thank Kate and Shanna for an excellent job on this project and for your inputs that will be really, really highly used in the UK and beyond. We're really grateful. Thanks again to the Road Safety Trust for the grant that supported us to do this work. Thank you to the iRAP dev team who have worked really hard to get all of this working within the iRAP feeder system. All of your inputs are highly appreciated, and we look forward to working with you all and implementing this and seeing it transform road safety across your network soon. So yeah, always be in touch. We'd love to hear from you. Thanks, everybody.
Thank you.
Thank you. Bye.